So here we're looking at the chain rule, or otherwise known as the composite rule. Sometimes derivatives can be a little bit complicated when we have composite functions. For example, this one here, we've got y equals 6x squared minus 5 to the power of 5. So we've got a function of a function. So our function inside is our 6x squared minus 5. And then we've got all of that to the power of 5. Now we could expand all that out with 5 different brackets and working through that way. However, there's a simpler way to do that. What we do is we use a substitution, which is u. You can call it any letter you like. U's the common one. And u is the inside function, so the bit inside the bracket, or that you could put brackets around it really, I guess. So in this case, we've let u equal 6x squared minus 5. And therefore, this now becomes a lot easier because now we've got y equals, this bit has become u, and to the power of 5. We can break up the functions using the chain rule, and we have this formula here. So dy over dx equals dy by du times du by dx. Now the first bit is dy by du. So that's the derivative of y in terms of u. So we'd work with an equation where it's got y equals something something u. And our second bit is the derivative of u in terms of x. So it'd be, the equation would have u equals something something x. So we'll look at it on the next. We'll use the same example. So we've got u equals 6x squared minus 5, and we've got y equals u to the power of 5. So du by dx, so we're differentiating u with respect to x, becomes 12x. And for this one, it's dy by du. We're differentiating y with respect to u, and it becomes 5u to the power of 4, using our differentiation rules. So we're going to use our formula from the previous page, and all we're doing is substituting in. So instead of dy by du, we're going to replace it with 5u4. And instead of du by dx, we're going to replace it with 12x. Now one thing that you have to do is substitute back. So we're going to substitute our u back. And our u, remember, is 6x squared minus 5. We can tidy that up a little bit to get 12 times 5 is 60. And our x goes at the front, and then we've got 6x squared minus 5 to the power of 4. We've got a different example here. So what we're going to do is going to let u, for this one, because it's all under the square root, that we're going to let u equal 2x squared plus 5x. Now y equals u to the power of a half. So here y equals the square root of u, and we can rewrite that as y equals u to the power of a half. Again, we differentiate each bit. So du by dx equals 4x plus 5. dy by du equals a half comes down the front, u, and a half minus 1 is to the power of negative a half. Use our formula again and replace our bits in that formula. So dy by du equals a half u to the power of negative a half, and our du by dx equals 4x plus 5. Substitute back in. So all we're doing is putting our u, which is here, back into our equation, which from there. Just tidy it up a little bit. Now what happens here is that this to the power of negative a half takes it back down to the bottom line. Now it's just this bit that goes back to the bottom line, and to the power of a half makes it the square root of. So this is on the top line because it's not to the power of negative anything. It stays with the 1 here. This 2 stays on the bottom, and because of the negative a half there, that goes back to the bottom line, and it becomes to the power, the square root of it. And that's using the chain rule.